or ADC0809 with 8051. But directly before going to the discussion of the interfacing, I shall give a brief idea about the different pins of ADC0809 or ADC0808. Now, here you can see in this picture, this ADC, you can see it has 28 pins. Now, out of these 28 pins, few pins have been used to give the input to the ADC. So when we talk about ADC, it means it will convert the analog signal or analog voltage into its corresponding digital value. Now, in this ADC, you have 8 different input lines to give this particular analog voltage. Now, out of these 8 input lines, you can select one at a time. Okay, so here the concept of multiplexer is coming. So if you can remember in multiplexer, what we have observed, if 8 lines, input lines are there, and you have to select one of the input from these 8 input lines, then you should have at least 3 select lines. So by putting appropriate values in the select lines, you can uh, select one of the input among 8 inputs. So in this case also, the same thing is done by the select lines A, B, C. Okay. So these are known as channel selection. A, B, C are known as channel selection. So these three things is going to decide where you need to give the input, analog input to the ADC. Okay. Other than that, it has D0 to D7 line. So D0 is the LSD bit and D7 is the LSB bit. Okay. So these are used to get the corresponding digital value. Means you have given one analog input, its corresponding digital value will be obtained through these pins D0 to D7. You can see pin number 17 to 21 here, 1, 2, 3, 4, 5, and this D3 is given here, then D2 is here, then D1 is here. Okay, so here you have 5, then 6, 7, 8. So 8 different pins are there to get the corresponding digital value. Okay. Now here all the details of each of the pin has been given, but in the right side, what picture you can see, this is given in a simplified form. So I am not going to discuss about each of these lines. Rather than I will discuss this figure, right side figure, where things are given in a more simple way. So you see, as I already mentioned, in this ADC, you have 8 input lines, IN0 to IN7, where any of the line has to be used as a analog input, means you have to give analog input signal in one of these 8 lines. Okay. The corresponding digital value you are going to get from D0 to D7 line. Okay. Then it has these 3 ABC channel to select one of the input lines from IN0 to IN7. So if you make ABC equal to 0, 0, 0, then you have to give the input in IN0 line. Likewise, if the values are 0, 0, 1, then you have to give the input in IN1 and so on. So as you have ABC 3 different variables, you can generate 8 different combination. One of the combination will indicate or represent one of the input. Okay. One of the input line. Now, other than these things, you have V reference positive, where you need to apply plus 5 volt, V reference negative, which has to be grounded. Similarly, here also you have ground that has to be connected to ground terminal. VCC has to be connected to 5 volt. Then here you need to apply the clock signal in the clock terminal. Other than that, 4 important pins are there. Okay. EOC, end of conversion, OE, output enable, ALE, address latch enable, and this start, or sometimes it is called as SC, start conversion. Okay. In many books, you will find that it is written, it is given as SC, that is stands for start conversion. Okay. Now, what are the function of these four pins? When we have to do the interfacing of this ADC0808 or ADC0809 with 8051, these pins play an important role. Now, what are the meaning of these different pins? Now, ALE stands for address latch enable. So when you are giving appropriate value in the channel ABC, for example, 000, my first input is getting selected. So that address will be latched by using this ALE line. Okay. Now, when you are doing some analog to digital conversion and you are interfacing your ADC with the 8051, in that case, you have to give appropriate value in the ALE to latch that thing. So what is the appropriate value? You have to do a low to high transition in ALE. Means ALE, initially you have to give a zero value, then you need to make it high to activate this ALE line. Then you have another important line, that is SC. SC stands for start conversion. So after applying the analog input, you need to activate the start conversion line. Then only the conversion will be started. What conversion? The conversion of analog voltage to its corresponding digital value. That conversion will start. How? You have to give an appropriate value to this SC line. What is that value? You have to give a transition from 0 to 1. Same thing, the way you have given a transition from 0 to 1 to activate the ALE, similar kind of thing you need to do for SC, that is known as start conversion. Now the next one is EOC. EOC is end of conversion. So the by default value, or in general value of EOC, what you should have, that will be 1. Now, when the conversion is going on, it will show a value of 1. When conversion is over, means when the analog to digital conversion gets over, immediately automatically it will get a value of 0, mean it will show a value of 0. So what you need to do after starting the conversion, you have to keep a track on this particular line, whether it is becoming 0 or not. If it is remaining 1, it means conversion is going on. When it reaches 0 value, or when it gets a value of 0, it means you have to understand that conversion is over. Now, when the conversion is over, then you have to do another thing, that is output enable. This next one, OE. OE stands for output enable. So what it is doing, you have to give an appropriate value to OE so that whatever converted value you have got, that can be taken to the controller. Okay. So you have to give a appropriate value or appropriate signal to the OE line so that whatever digital value you got in your analog to digital converter, that value can be taken to the 8051. Okay, so these are the functions of the different pins of ADC0809 or ADC0808. Both are having the similar kind of pins. 28 pins are there in total, whether it is ADC0808 or it can be ADC0809. In both the case, you have total 28 pins, and these are the functions. Okay, now let's talk about the interfacing part. Now we shall discuss about the interfacing of this ADC0808 or ADC0809 with 8051. Now we'll be focusing on this particular thing. So I have already drawn one picture how to do the interfacing. So here I have selected my own configuration. It is not mandatory to do this connection like this way. any method can be followed, or in the question you can get different type of configuration, and based on that only you need to you just have to do minor changes in the coding. Okay. So here I have taken one example where I have done my own configuration. So you see, as I already mentioned, in ADC0809, or it can be ADC0808. Okay. So it has three different channels A, B, C. Okay. What just few minutes before I mentioned this ADC, A, B, C are the channel selection line. Now, what are the function, or what is the main function of these three line? By putting an appropriate value to A, B, C, you are going to select which input you are going to use for the conversion operation. For example, if I put A equal to 0, B equal to 0, C equal to 0, which line will be getting selected? IN 0. So you have to give the analog input to the IN 0 line to get its corresponding digital value. Now, for example, if I give 0, 0, 1, okay, ABC value, if I take 0, 0, 1, then definitely you should give input to the second line, not in the first line. So you should give input to the IN 1 number line. Okay. And suppose if it is 0, 1, 0, then you should give in IN 2 and so on. Okay. Now, so this ABC line I have connected to P1 P1.0 is connected to A, P1.1 is connected to B, P1.2 is connected to C. So I'm talking about port 1 different pins of 8051. This configuration I have used. Okay. Then the data line D0 to D7, where you are going to get the corresponding digital value, that is connected to port 2 of 8051. Then ALE, address latch enable of ADC, is connected to P1.3 of 8051. Then start conversion line is connected to P1.4, end of conversion is connected to P1.5, OE or output enable is connected to P1.6, and P3 I am going to use to show the digital value what I got in P2. Okay, so that's why I have used some LEDs in P3, means as you know, in P3 8 different pins are there. I have connected 8 different LEDs to the P3 line to show what was the value I got through P2. Okay, and you know, in P2 what value I got? The corresponding analog, the corresponding digital value. Means what I am trying to say, what analog input I have given, its corresponding digital value I will get through D0 to D7, and that value will be taken through P2, and that will be shown by these LEDs through P3. Okay. So this is the configuration I have made to show how to do the interfacing of 80 of ADC 0808 or ADC 0809 with 8051. Okay. So in the next lecture, I'm going to discuss what are the steps to be followed and how to write the assembly language code to get such configuration. Thank you very much.